This video talks about two types of searching, linear search and binary search. These are the searches most widely used algorithms. So in linear search, the input to the linear search is set of data, or the number of elements, then the elements on which you are going to apply your search. Then how many elements are there? Then what item you are going to search? These three inputs are significant to linear search. That is, you are searching something in the list of items available. So the list can be implemented either by using array, or you can implement by using collection data type. In Python, like set, tuple, and list. So, but there you have some predefined libraries to search a particular item in the list. So, whereas you can use this linear search algorithm where you don't have predefined libraries. So, the algorithm is how it works. So, you are given with a set of items. So, you are going to search the item one by one. You are going to search the item X. For example, assume that X is the item you want to search in the given list of items, which is stored in the variable array, and n is the number of elements. So this array is the input which is holding all the elements, and n is the number of elements in the array, and x is the item you are going to search. So since you are going to do the searching process repeatedly for n number of times, so it is better to use for statement, looping statement, any looping statement supported by the programming language. You can see here, this is the for loop. It follows the syntax of Python for I. So I is the control variable in range. So range is the predefined function. It is used to iterate through the inputs, iterate the inputs from 0 to n minus 1. Since n is given, but it iterates from 0 to n minus 1. So inside that, so only one if statement, what it does, it checks whether that item is equal to the item you are going to search. That is, if array of I equal to x, then the element is present in the list. So you can return the index of the element. Otherwise, so if it is present, it returns from the function. Otherwise, it continues searching with the next element, the fourth element, and so on till you reaches the end of the element in the array. So if the element is not found, then the function linear search, it returns a value -1. So whenever you are receiving value -1, so it means that the item you are going to search X, the X is not available in the list. So it is also called a sequential search, because you are searching the element from the beginning to end of the from the first element to the end of the list. Then moving on to binary search. So binary search is another searching algorithm. So which this algorithm works based on dividend. So it is, here for this algorithm, the input is array of elements, then X the item you are going to search. So how the algorithm works, for this algorithm, the elements in the list must be in sorted order. So for example, in this algorithm, array is a variable which is going to store all the list of numbers, and to proceed to begin with the binary search process, the numbers in the array variable must be in sorted order. So how the algorithm works, this binary search algorithm, it divides the list into two halves. There's the first half, then the second half. The first half, after dividing the elements into two sublists, the algorithm checks whether the middle element is equal to the element you are going to search. So if it is same, then the element is present in the list. So it returns the index of the element. Otherwise, check whether the element you are going to search is greater than the mid element. If it is greater than the mid element, then the first half will be taken for searching. Otherwise, the second half will be considered for searching. For example, so you have a number like 4, 5, 6, 7, 8, 9. So you have 5 numbers. So in this middle, and assume that you are going to search the number 5. You can see in the list, the middle element is 7. Middle element is 7. But the item you are going to search is 5. So the mid element is not equal to 5. It comes to else part. Here checks whether this 5 is less than the mid element or greater than the mid element. Okay. Since the item you are going to search is less than the mid element, then this first half will be considered for further searching process. You can see 4 and 5. So this sub list will be ignored, will not be considered for searching. Now again, when it comes to 4, 5, again the list will be divided into 2. That is 4 will be in one list, 5 will be in another list. Now here the mid element is, so it's 2 by 2, it is 1. So that is the 1 is going to be the middle element. So 4, whether it checks whether 4 is equal to 5, it is not equal. So then what happens? So the second, the 5 will be considered for further searching. So now the 5 equal to 5. So the element is present. Then the index of 5 will be returned from this function. If the element you are going to search is not present in the list, then the function returns a value -1. So the time complexity of this linear search algorithm is, it is big O of n. So whether the element you are going to search is present in the say first element, second element, or third element. So irrespective of that, what happened? All the elements in the array will be checked for considered for searching process. So the loop iterates from 0 to n-1. So the time complexity of this algorithm, linear search, is big O of n, whereas the time complexity of binary search is, it is big O of log n, because always we will consider only half of the list for further searching process. So it is not, the for loop will be iterated for less than n. The number of times number of times equal to less than n. So it must be big O of log n. So log n is, it is smaller value than n. So the time complexity of binary search algorithm is big O of log n. So, but when compared to binary search with the linear search, when you have a huge amount of data, then your binary search algorithm works efficiently than linear search algorithm. The only constraint to the binary search algorithm is the element must be in sorted order.